On this lesson, we're going to be looking at inverses again. So this is exponential and logarithmic inverses. So if you remember, inverse relations interchange the x values and your y values. So remember, all we're doing is switching our x's and y's when they're inverses. So a relation and its inverse relation reflect over the line y equals x. Remember, we've talked about that multiple times on when we're talking about inverses. So the inverse of f of x is the symbol, which is read aloud as f inverse of x. So first step is to rewrite your y as f of x or f of x as y, because remember, those mean the same thing. Second step is to switch x and y, and then you're going to be isolating in solving for y. So you're either isolating the exponential or logarithmic term. Solve for y by rewriting. So make sure at the end you rewrite in function notation. So example 1, we're going to be given f of x equals 2 to the x. This is exponential. And we're going to find the inverse of that. So inverse of an exponential is a logarithmic equation. So after we do that, we're going to graph both functions on the same grid. So first step is to change my f of x to a y. Second step is to switch x and y. And then we're going to solve for y. So what we're doing here is we are rewriting to logarithmic form. So remember, we went over that on lesson maybe 10.3. So we are switching it to log form instead of exponential form. If you want, you can rewrite it, your base and the exponent. If you want to rewrite it on the left side, it's the same thing. So remember, you always start with your base. So I'm going to change it to log base 2 of x equals y. So I changed it from exponential form to log form. Notice we now have y by itself, so I'm just changing that to, instead of y, I'm putting f inverse of x and then log base 2 of x. So there's my inverse equation. So again, once you get to this point, to get y by itself, you're just rewriting it from exponential to log form. Make sure this 2 is a base and not just a regular number there. So make sure you bring it down and make it a little subscript. So we're graphing both. So we can use a calculator. So this is exponential 2 to the x. Actually, we went over this the other day. If you plug in a -2, you get 1/4. So -2, 1/4. -1, 1/2. 0, 1, 1, 2, and 2, 4. You can also just plug in the calculator, look at your table. So there's our original. I'll just call it f. And then our inverse graph, which is log base 2 of x. So if you remember, the other day I showed you how to change your base on the calculator. So if you first go to y equals, and then you're going to type in log base 2 of x. So go to math. Remember, go up to log base. And then you can go in and change your base to 2, and then you're taking the log of x. So whenever you look at your table, your points will be 1, 0, 2, 1, 3, 1.58, 4, 2, and then remember, your log function will be approaching that y-axis. So there's my inverse. Also, remember, we said before, on inverses, it should be a reflection over the line y equals x. So if you wanted to draw that y equals x line, so that way you can visually see that it is a reflection across that line. Okay, so let's try another one. Example 2, this time we're starting with log. So first step is to change my f of x to a y. Second step is to switch your x and y. And then we're solving for y. So I need to go ahead and subtract 5. I want to get log by itself. So once I have the log by itself, we're going to change it to exponential form. So if you remember, if there's a log with no base, that base is 10. Also, if you want to rearrange it to where your log, you're always starting on the log side. So if you wanted to rewrite it, you could. So you're starting with your base. So my base would be 10 raised to that power, which is x minus 5 equals y. So once we get the log by itself, then you can rewrite it with exponential form. Notice I have y by itself. I'm going to replace it with just f inverse of x. And there's my inverse of log of x plus 5. Okay, so you can plug this into the calculator. So we are starting with our original function, log of x. So that means you can just use that common log button on the regular log or calculator screen. So if you go to y equals, you're just typing in log of x, and then you're closing your parentheses, add 5, and then you can go to the table. So points would be 1, 5, 2, 5.3, 5.4, 5.6, so there's my log. So that's my original f. I'm just using the calculator and looking at the points from the table. And then I'm plugging in this one. So go back to y equals, do 10 raised to the x minus 5 power. Go to your table. So my points would be 2.001, 3.01, 4.1, 5.1. And remember, your exponential graph will be approaching the horizontal asymptote, which is the x-axis in this case. So you can draw out, if you want, you could draw out your y equals x line. And notice that it is a reflection over that line. It's the same image on both sides there. Okay, so finding the inverse equation first and then just graphing both of them. Again, you can use the calculator, plug it into y equals, find your points, graph them. You could also check your points, make sure that you're switching your x and y on the points. Flip over. So now we're going to just find the inverse algebraically, so just like what we were doing. So first thing we need to change f of x to y, and then switch your x and y. I'm solving for y, so I want to isolate the base and the exponent. So I want to get rid of the 2 by dividing it. And then once I have my base isolated, then I can change it to log form. Again, if you want to rewrite it with the, because you're always beginning with your base. If you want to rewrite it as this, that's fine. So notice my base is 10, which means I would just have a common log with no base of x over 2, and that equals y. So using around the world is what I like to call it. So then just replace with your inverse symbol. You can either use parentheses or leave it as x over 2, but you shouldn't have a base there because the base was 10. So remember, that's just a common log. So there's our inverse equation. Okay, looking at the next one, first step is to change f of x to y. Switch your x and y. And then you need to isolate your y. So make sure you're isolating either the base and exponent if it's exponential, or isolating the log if it's a log function. So I first want to add 8. I also want to get rid of this by multiplying both sides by 3. When I distribute that, that's going to be 3x plus 24. Now, since I have my log term by itself, I can rewrite it in exponential form. Again, if you want to rearrange it to where your log is on this side, it doesn't really matter. As long as you know to start with your log when you're rewriting it, then that's fine. So notice it's a natural log, so my base is e, even though it's not there. So e raised to the 3x plus 24 power equals y plus 2. Now in this case, when I change it to exponential from log form, notice that I still don't have y by itself. So my next step would be to subtract 2. So I'm having to go one more step with this one. And then I can change it to inverse function notation. So there's my inverse. So if you're starting with a log, switch x and y, isolate your log term, and then change it to exponential form, which we were doing the other day. If you're starting with exponential, switch x and y, isolate the base and the exponent, then you can change it to log form. Okay, let's try another one. This one I'm starting with exponential because I have an exponent. I want to change it to log form once I switch x and y. So I need to switch them because I'm finding the inverse. So once I switch them, you have to isolate the base and the exponent. So I need to subtract 3. Oops. Then I'm going to change it to log form. So again, if it helps you, you're always starting with your base. So I'm just going to rewrite it with the base on the left side, and I wrote the wrong number there. Okay, so start with your base. So I'm going to have, since my base is e, I'm going to have a natural log, and I don't need to write the e for the base, of x minus 3 equals y minus 2. So notice here that I don't have y by itself, so I need to add 2. And that gives me natural log of x minus 3 plus 2 equals y. And then I can change that to function notation. So remember, if you're starting with exponential, you should end up with a log. So once you've isolated the base and the exponent, make sure you're changing it to log form. Okay, inverse properties, we talked about this the other day. So remember, an exponential and log function undo each other. So if they have the same base of your exponential and the base of your log, they cancel each other out. So if we look at part A, I have a base of 5 of my exponential, and then I have a base of the log. Those cancel each other out. I'm left with x minus 1, or 8x minus 1. So if you wanted, if you're not understanding this, we could change this to log. So I would have log base 5. I'm looking for this equals log base 5 of 8x minus 1. That's why it's canceling each other out. So if you change that to a log, you're just looking for that 8x minus 1. So if that doesn't make sense, you can rewrite it like this, but it's a lot more work. So as long as you can see if your base of your exponential, base of your log are equal, they cancel each other out. So they equal, so you get 8x minus 1. So this one, notice my natural log has a base of e. The exponent of the base of this exponential is e, so they cancel each other out. You're left with x plus 7. This one I have a base of 10. This one I have a base of 10. They cancel each other. I have x over 2. This one, my base of the log is 2. My base of this exponential is 2. So again, they cancel each other. You're left with negative x over 3. Okay, so I want you to pause the video, go ahead and do the next 4, and then you can press play again and check them with what I have. So notice E, you have a base 10, they cancel, you get x. Next one, base and base equal each other, you're left with 10 minus x. Base, base, you get x. And base, base, you get 5x. So that's using the inverse property. They undo each other. So this last part, we've talked about composition functions before. We take a function, plug it in for x on the other function. We always want it to equal x if they're inverses, and then vice versa. Take the other one and plug it in, make sure it equals x. So if I look at this first one, I'll start out with taking g and plugging it in for x on f. So I'm going to have e. Instead of x, I'm putting natural log of x minus 4. And then I have a plus 4. So notice here that I have e. Notice my 4's will end up canceling out, so I just have natural log of x. So notice this is a base of e, this has a base of e, they cancel each other, you're left with x, which is what we wanted if they're inverses. But it has to be the same way both ways, so now I need to do the opposite and take this one, plug it in for this x. So I have natural log of e to the x plus 4, and then I have a minus 4. So this one, notice my base is e, my base is e here. Those both cancel. I'm left with x plus 4. Then I have a minus 4, which also equals x. So yes, these would be inverses of each other. So you're having to use that property law that we just talked about up above. Bases are the same on a log, on a base of an exponential. They cancel each other, so that way you know what it equals. Next one. So I'm going to take this, plug it in for x. So I have log of base 4. Instead of x, I'm putting 4x minus 8 minus 8. So notice this base cancels with this base. I have x minus 8 equals, not equals, minus 8. And then notice that does not give me an x. That would be x minus 16. So if it doesn't work, it has to be equal to x. So we know these are not inverses of each other. Okay, so next one. So take this one, plug it in for x. So I have log base 8 of 8 to the x plus 12 power. And then I have minus 12. So notice that this base of the log is 8, so is this one over the exponential piece. I have x plus 12 minus 12, which does give me x. And then make sure you check the other way, plug this in for x here. So you're going to have 8 raised to the log base 8 of x minus 12. And then you have a plus 12, still in the exponent part. So notice the log base 8, they both cancel. Negative 12 plus 12 cancels. You're just left with x. So yes, these would be inverses of each other. So that's using composite functions, just taking one function, substituting it in for x on the other function. They both have to equal x if they are, in fact, inverses of each other. Okay, let me know if you have any questions on inverses dealing with exponential and logarithmic functions.